everyone. Today we will understand how to do the standalone deployment for the Hyperswitch Card vault. Uh, a disclaimer: before, if you have used the Hyperswitch CDK to do a deployment, then you wouldn't be required to do a separate deployment of the Hyperswitch Card vault. This is specifically in the case where you are already set up Hyperswitch using something like Helm charts, but you have to set up Hyperswitch Card vault separately. This is also similar to the Hyperswitch CDK deployment, where you just have to run a script and the script will itself set up all the components that are required to complete the setup of the card vault. So we'll start with what are the prerequisites and how to start with the deployment. As you can see in the docs, there are a few prerequisite steps required before actually running the CDK script. The first step is to create a new user which we can use to run the script. Be aware, the operations that are required to run the CDK scripts are setting up KMS and a few other crucial steps. So to make things easier, we will just create a user with administrator access. Following that, we will have to copy the AWS region, the access point, and all the other information in our terminal. Let's do that. So in the terminal, we will start by setting up the region. So AWS region. In today, while setting up the stack, I will be setting it up in London, that is US West 2. As explained in the documentation, we will also have to set up the default region. Next, we will also have to generate a master key as specified in the documentation. Let's follow that step later. First, let's install the CDK script via GitHub. So to install it, let's run these commands. We are closing the repository and let's wait for a minute. Yes, perfect. So let's start by running the install command. Okay, while installing, it might try to install a few prerequisites like the AWS CLI, the CDK, toolkit, Node.js, and a few other dependencies, some of which might require root access. So let's do that. As you can see, some of the dependencies are already installed, so it is only trying to refresh them. Moving forward, the first thing that the script asks us is whether we have set up the local environment correctly by setting up the AWS default region and other things in your current terminal. In my case, we have done that already, so let's move on by saying yes. Next, it is asking about the VPC that we need to use in order to do the deployment. So you won't always need to have a VPC to do a standalone deployment, as there is an option specifically provided in case where the VPC is created for you by the script. But in most cases, if you're trying to set up the locker in your environment, you would already have a VPC which you might need to use. So in my case as well, I have a VPC that I need to set it up with. But if I have to use the VPC, there are a few other prerequisites which we need to fulfill. That is, to run the CDK, the locker needs to be set up into a private subnet which has access to the internet. That is, a private subnet with egress. If you have used the default settings for setting up the VPC, you might not have created a NAT gateway which can allow us to give that kind of access to the subnets. What we can do is, we can manually do those changes in the AWS console. So let's do that. I'm opening my AWS console. In the console, you can see my VPC is locker example VPC. Let's open it up. Let's see if we have any subnets in it. So, of course, we have quite a few subnets here, but none of the private subnets are connected to a NAT gateway, or they won't be able to access the internet on their own. So what we can do is, we can create a NAT gateway which can actually allow us to do this. So let's go to NAT gateway and let's create a NAT gateway. I'll name it locker example NAT. The subnet that needs to be provided here is going to be a public subnet. Why? Because the NAT gateway will be exposed in that public subnet for letting our private subnets have access to the internet. So let's choose the subnet in EU West 2A. Perfect. What about the elastic IP allocation? We can just allocate it directly using this. Do this. It's allocated. Let's create a NAT gateway. It will take a few minutes to create. Until then, we can set up the NAT gateway in the routing table. But which routing table do we need to use? Let's see that as well. So the first private subnet is exposed to RTB private 1 and the second one is RTB private 2. Let's add that NAT gateway to both of these routing tables. RT, this is the first one and this is the second one. Let's go inside. And here we can just say edit, add. We can add the internet NAT gateway. You can see we already have a NAT that we have created. Done. Yep, awesome. Let's add it to the second one. Same process. We'll go here. We'll mention the internet, NAT gateway, and the one that we have created. Save. Perfect. So let's copy the VPC ID so that we can paste it there. Let's copy it and perfect. The NAT gateway is up and ready to go. Let's paste that NAT ID in the shell script and continue with the installation. Perfect. Now let's see what it says. The following subnet IDs are optional and can be skipped in case. So in some cases where you want to specify your own subnets, where you want to have granular control over where the locker should be located, you can provide the subnet and the availability zone of the subnet here to specify exact location where the locker needs to be spawned. But in my case, I don't have any preference. I'll just go with the default, whatever the script chooses. Same goes for the database for the locker. The database that is to be used by the locker to store your cards should also be provided with subnets. But in our case, I'm not going to be picky and I'm going to let the script decide. But if you were to choose one, you need to provide at least 2 subnets which are available in 2 separate availability zones as to improve and maximize the availability of database in case something happens to one of those zones. Continue. Okay. It is asking for something like master key. It is also given us a command. Bear in mind, to run this command, you might need cargo installed. I already have it, so I'll probably just run this command in a separate shell. New split window horizontally. Perfect. And I'll just run this command. If you wish to generate these keys separately, that can also be done. In my case, I'll just be generating these keys on my computer. So let's try to understand what these keys stand for and how are they going to be useful further in the installation and setup. So these are the key custodian keys. What that means is when you start the locker will not immediately start serving requests and giving you access to the internal data. What it needs is 2 distinct keys which needs to be provided to the locker APIs in order to unlock the locker. That is, the master encryption key that exists in the locker is encrypted by 2 layers. That is the KMS encryption and these key custodian keys. KMS encryption can be bypassed using the basic run command. But to actually start a locker, the maintainer of the locker needs to be there in person to provide these keys in order to unlock and start the locker. This provides an extra level of security as you're storing quite a few sensitive data in this locker. Let's see if the master keys are generated. Oh, they are. Awesome. So what I'll do is, for ease of use, I'll store these keys in my password manager. Perfect. Okay, as you can see, this is my master key. I'll just copy it and paste it here. Okay, it is asking for a database password. I'll try to keep it as difficult as possible so that no one is able to get access to my database. Okay, awesome. Okay, now it is asking for something like a jump server to be installed or not. So let's understand what a jump server is. A jump server is a server which lets you access the locker, as locker is not directly exposed to the internet, as the primary purpose of locker is to be accessed by another application in the same VPC. So, but to run those commands, to unlock the key custodian of the locker, we need a way to access the locker. So for that to happen, we need a jump server. So let's say yes. So let's wait for the setup to do its job. Awesome. It has already picked the region and the account. It is trying to bootstrap. So if you are trying to run a CDK script for the first time in your region, there is something called as a CDK toolkit which needs to be installed. In my case, it is not installed, so it is trying to install that first before actually starting the installation for the deployment. So let's wait for the CDK toolkit to be installed. This is actually very quick and should happen in less than a minute. As you can see, the synthesis is completed and the deployment of the card locker has started. The synthesis and the generation of the change set might take a few minutes, and the actual installation will take around 5 minutes, as the majority of the time goes into setting up the Postgres database, as it not only sets it up in a single region, it sets it up in 2 availability zones. So as we wait, we can see all the components that are being created. In the meantime, let's discuss about how tokenization works and how the card locker is used inside Hyperswitch. Whenever making payments, we see an option where we can save cards so that we can use that card for further transactions. But to save a card, all the organizations who are actually doing these payments needs PCI compliance, as they can't as PCI compliance provides the customers an extra assurance that their card has been stored safely. But not everyone might have PCI compliance to begin with. This is where Hyperswitch comes into picture. The card wallet is already PCI compliant, and the PCI compliant for the card wallet can be achieved easily and quickly. So Hyperswitch provides you with an extra layer of abstraction, and the card is stored in a more secure thing which already has been certified to be PCI compliance in RStack. Though being prepared to be PCI compliant doesn't mean the card wallet is PCI compliant in the first place. The PCI compliance isn't necessary for a piece of code. It's more towards the domain that is actually going to use the code. But as it's an audit, and as we have already gone through one of them, the card wallet is ready to be used and to be certified for being PCI compliant. So as the deployment has been completed successfully, the next logical step is to unlock the locker so that it can be used by the applications that you have planned to be using the card wallet. In our case, it should be Hyperswitch. But before doing that, we will unlock the locker by first downloading all the SSH keys required to reach the locker. To do that, let's just download the first jump SSH key. Secondly, there is the actual locker's SSH key. Perfect. So we can actually start with actually going into the jump server, and from there going into the locker to unlock it. So first, before doing that, we have to set up the permissions properly for the SSH keys that we have downloaded. So let's do that. chmod 400 locker jump key chmod 400 locker.pem. Perfect. Let's see if we are able to SSH into the jump server. to SSH into the jump server, the IP address required is provided right here. So let's just copy this guy and SSH I locker jump EC2 user, that is the default user that is created for the Amazon Linux image, and the IP address. Let's say yes. And as you can see, we are successfully able to SSH into the jump server. But we also need to SSH into the locker server. How can we do that? To do that, we need to copy the locker's SSH key into the jump server. But let's see if we are able to reach the locker at all. So let's do a curl this. The port that is the default port that is exposed by the locker is 8080 and health. And as you can see, health is good, but that does not indicate that the locker has been unlocked yet. The APIs to store card, retrieve card, and delete card from the locker are behind a different server that actually manages the key custodian keys. So in order to unlock the locker, we need to provide it with the key custodian keys that we generated a little while ago. To do that, we will have to call, and we can say the locker's IP address 8080 custodian key 1 header. The command that I'm typing is also available here, as you can see. Then data. Key. So we have to enter the key 1 here that we had generated. I can get it from my password store. Pass show lock example keys. This is the key 1. Perfect. I'll paste it here. Let's say enter. As you can see, received key 1. Similarly, we'll also enter the key 2. The API just differs by the URL. Instead of key 1, we'll have to paste key 2, and instead of providing the key 1 that we have generated, we need to provide the key 2. Here we go. We'll copy this second key, press enter. The key is received. Finally, it's just the matter of decrypting the locker. Just let's say copy this guy 8080 custodian decrypt. As you can see, the decryption is successful and the locker is ready to be used. If this fails by any chance, which means the keys that you're using might not be the right one, or maybe the locker hasn't initialized properly. But as you see in the steps, if you use the CDK script to deploy the locker, not only is it easier to deploy it, but it also is easier to set it up and to use it further. Now, as the setup has already been completed, let's talk about how to use the locker. Even though we have set the locker up, you will still not be able to communicate with the locker without the JWE and JWS keys that are required. If we check the output of the CDK script, you can see there are two very specific output variables which are given out. That is locker public key and tenant private key. These keys are required so that we are able to communicate with the locker. Let's see how they look. But in our case, we would not be downloading them. We will not be using them, as this is purely a locker setup, and the only place where we can use this are inside Hyperswitch configuration. Or in your case, if you are setting up the locker for your own application, you need to use these keys inside your own application. Let's paste this here. Let's see how it looks. As you can see, it's a public key, and similarly, if we check out this, it is a private key. So we need to use the private key to sign our payload, that is to be sent to the locker, and then use the locker's public key to encrypt it. This would provide both security and verification against tampering and anyone else trying to communicate with the locker. So overall, this was the entire setup of how to set up locker on an AWS environment with your own VPC. Thank you, and see you in the next one.